Hey guys, my name is Jersey, and this is my AP Stats Quideo number 3. I'm start off with my basic question here, which is dealing with proportions of car colors and probabilities. So, part A of this question is asking us what's the probability that the vehicle chosen has any color other than the 6 that are listed, which are silver, white, black, dark green, dark blue, and medium red. So, in order to find this probability, you would have to do 1 minus all the colors that are listed. So what would you do is you would add them all up, which would get 0.705, and then you subtract that from 1, which would be 0.295, which would be your probability, which is highlighted in a percentage, which is 29.5%. Now, moving on to part B of this question, it's asking you what's the probability that a random chosen vehicle is either silver or white. So here's your formula right there. I put just probability of silver or white, which is also probability of silver plus probability of white. So in order to find this, you would need the probability of white and silver from the data in the question above, which is 0.176 and 0.172. And what you do here is you would add them, and you would get 0.348, which is your probability and your answer for this question, which can also be read as 34.8%. Moving on to part C of this question, the final part of this question, it's asking you, when choosing two vehicles at random, what's the probability that both are silver or both are white? Up here in the top right next to your question is the formula for this question, and at the bottom right here is the work. So what you do is you would take silver and silver twice, which is 0.16 and 0.176 and 0.176, and multiply them to get 0.0310, and then you take the probability of the white, which is 0.172, take that twice, multiply it, and you get 0.0296, then you add them both together, and you would get 0.0606, which is also 6.06%, which is your probability for this question. Now, moving on to the advanced question for Quideo number 3. This question is pretty much dealing with antibiotics and how they will prevent colon cancer. If you want me to read this question right here, it says, people who eat lots of fruits and vegetables have lower rates of colon cancer than those who eat little of these foods. The fruits and vegetables are rich in antioxidants such as vitamins A, C, and E. And they just want to know pretty much, will taking these antioxidants prevent colon cancer? So they do a trial on 864 people who are at risk of colon cancer and divide them into 4 groups of 4 different vitamins for them to take daily for 4 years. Part A of this question wants to know the explanatory and response variables. And this one's pretty self-explanatory, no pun intended. The explanatory variable is the antioxidants, and the response variable is the colon cancer. Now moving on to part B, I want you to do an outline design of the experiment. So right here I have 3 steps. And for the first step is you assign the 865 people to 4 different groups with 216 in each group, and you do this randomly. Then you give each individual subject in all of the 4 groups a treatment, and the 4 treatments you have to choose from are daily beta-carotene, daily placebo, daily vitamin C and E, or all 3 vitamins. And then you do this for 4 years. Then the third step is to compare the findings among the different groups related to colon cancer rates. Moving on to part C, it asks you to assign labels to the 864 subjects and use table B starting at line 118 to choose the first 5 subjects for the beta-carotene group. Then after you do this, right here I wrote down all the numbers from line 118 for table B, and then I chose the first 5 subjects, which is 731, 253, 304, 470, and 296. Now moving on to part D of this question, it says the study was double-blind. So it wants you to find out what this means in the context of this problem. So for this answer I put that the fact that the study was double-blind means that both the subject as well as those administering the vitamins for the study do not know who or what they received. Now moving on to part E, the final part of this question, it wants you to suggest some of the lurking variables that could explain why people eat lots of fruits and vegetables have a lower rate of colon cancer. And one of the possible lurking variables I put was that or variables that relate to a healthier lifestyle. Now moving on to the final part of this question, or this Quideo, the AP question, which deals with 2 antibiotics that are available for treatment for a common ear infection in children. Antibiotic A is known to effectively cure 60% of the time, while treatment B is known to effectively cure the infection 90% of the time. And treatment B costs $80 compared to treatment A, which costs $50. So, part A of this question wants to know what's the probability that a child will be cured if a doctor chooses plan 1 or 2. So for the first part, plan 1, use this formula over here. P cure equals P for the probability of A plus the probability that it's not A times the probability of B. So what I did for this was I took the probability of A, which is 60% that it works, 0.6, plus the probability that it's not A, 0.4, times the probability of B, which is 0.9, which is altogether equals 0.96, or 96%. And I did the same thing for plan B, but just changed up the A and B's. And actually, when you figure all this out and put it into the formula, it turns out to be 0.96 as well. So both plan 1 and plan 2 have a 96% probability that a child will be cured if chosen. So moving on to part B of this question, it wants you to compute the expected child, or the expected cost per child using plan 1 or 2. So at the top, I just put a few reminders that treatment A costs $50 and treatment B costs $80. And then here, right below that, is my formula for plan 1 and the expected cost. So to figure out this formula, I put the actual cost of treatment A times the probability of treatment A, which is 0.6, so 50 times 0.6 is $30. And then to the right, I added that against the entire total, which is 50 plus 80, and that's 130. And then I put it against the probability that it's not A for treatment, so it would be 0.4, so 130 times 0.4 is 52. And then you add it all together, and 30 plus 52 is 82. So the expected cost for treatment A is $82. Then I did the same thing for plan 2 on the bottom, just switched out the cost, and when you do that, it gives you a total of $85.